Hello, everyone. Welcome to episode 28 of the Day Zero podcast. I'm Spectre. With me is Z. Before we jump into any topics, I do want to say that we won't be doing the scheduled streams on the Fridays anymore. It's been kind of hard to keep with them. Like for the past couple Fridays, they haven't really been going on. So we're gonna do spontaneous streams. We're not gonna stop streaming or anything like that, but they're just not gonna be scheduled on the Fridays. I did just want to put that out there, especially because this week I'm not gonna be here on Friday. So yeah, just wanted to get that out of the way that we're not gonna be doing the scheduled ones anymore, but we are gonna be still doing spontaneous streams here and there. But yeah, we can jump right into some news. We have an exploit.
The first bit of news actually isn't really news, but I did want to do a little bit of an update regarding the Sudo exploit.
Yeah.
Which talked about that last week, so I don't want to go into too much information now, but I did want to correct myself on it. When we were talking about the exploit last week, we had mentioned that it was a stack-based overflow, which, of course, and I even brought up this piece of code on screen. But you can notice there, it's a static character buffer. Keyword there being static. So this is actually put on BSS, not on the stack, which actually makes the exploit a little bit more interesting because you're doing kind of a data overwrites to get your code execution. If you're actually interested in an exploit technique, there have been a number of people now that have gone and done write-ups. If you Google the CV number, you'll find a number of people doing that. But the gist of it was that Sudo, before it ends up calling the AskPass program, will restore whatever user ID and group ID that Sudo was run with initially. So you can overwrite that, so it'll run whatever the AskPass program is with, or as root. So if you can set that, which it gets from the environment, if you can set that to some sort of shell or some program that will go ahead and execute a shell, you're able to get your root shell that way. So exploits have been written for this already. And it's definitely a little bit more straightforward of an exploit than we were discussing, since you don't really have to deal with ASLR at all. You don't have to deal with canaries, which are enabled on Sudo.
Yeah, so that's a good correction, because yeah, I'm surprised we missed that on the stream, but
well, it's just the one little word there. I mean, when I kind of looked, I'm just like, I had heard everybody saying it's stack already, so I just looked, oh yeah, there it is on the stack, and moved on. I didn't, just completely ignored the fact that it was static. So yeah, I kind of wanted to bring that up, just clarify things there. I mean, we make mistakes, so I'm sure this won't be the last.
Yeah, and another kind of mistake I made was we saw there was some news that put out yesterday that there was going to be a law enforcement action put out in regards to cybersecurity. So when I read that, I kind of read that as they're going to try to make like some kind of policy change or something. But we actually have a PDF here, and it was actually a criminal indictment of the people behind the Equifax hack that happened a little while back.
Yeah, that was 2017, the hack.
Yeah. So, obviously, all these people, I don't even think they're in the USA. I think they're in China, and they're probably never going to leave China. So I'm not...
Well, at least they're not going to travel to the US anytime soon now.
Yeah.
It is interesting. Like, they are directly calling out the PLA. There's very specific. They're members of the People's Liberation Army, so China's army. Like, they're calling it out as the military being behind it. The other thing is that I believe, of course, being a PDF here, they don't let you search this, but they do make mention of it basically being the old Struts vulnerability that ended up, well, they make explicit mention that Struts was used, so I'm going to assume in 2017 there were several code execution vulnerabilities in Struts. I think a couple of them will have come out after this, but Strut Shock, I think, was the name that tended to go by at the time, back in March.
Sounds familiar. I think
this also started. Well, we weren't doing the exploit, or we weren't doing this podcast then, so we have nothing to tell people to go to.
I thought there was something else with Struts earlier this year, though.
Well, it's come up because deserialization. One of them was a deserialization remote code execution in Struts.
Okay.
So could have come up when we were talking about other deserialization issues. But yeah, so on or about March 7th, and I believe that the Strut Shock exploit was also in March. Maybe it was around the same time. Nonetheless, they don't give a lot of details, but the fact that they're mentioning that it's a vulnerability in certain versions of struts, I'm going to make the assumption that it was one of those that were released just right around the same time.
Cool. Yeah. So like I was saying, I put out a tweet on the Day Zero Twitter, thinking it was more policy change, but it was just the indictment. So not as worrying as I thought it would be, to be quite honest. So ZDI put out a post just today announcing a targeted incentive program for Trend Micro products. So every so often ZDI do this. They put out like kind of like a blitz on certain products where they offer greater rewards for bug bounties on that. And so obviously this was just put out this morning. So I haven't looked too much at the blog post, but it seems the Trend Micro products Apex 1, Office Scan, and Deep Security are all going to be receiving more incentivized payout. So up to $7,500 for RCE, $5,000 for authentication bypass, $5,000 for remote information disclosure, and $5,000 for LPE. So, if any of you are,
that's just it. It's Trend Micro, and Trend Micro owns ZDI, so obviously there's kind of the overlap there.
Yeah, but if any of you are looking to do some bounties and stuff, and you're interested in those, upscaled payouts, that might be of interest to you.
Yeah, I mean, this seems kind of on par with what we're seeing out of some of the hacker ones for some of the more software-based issues, so not like your web applications. Definitely seems a little bit above them, but it's not like out of that range. So you can still be looking at HackerOne and such for similar bounties. That said, I did find it interesting. They mention in here some numbers. In the first 3 years after Trend Micro had purchased ZDI, first 3 years they purchased 310 related bugs, but in 2019 they only purchased one Trend Micro bug. So that's a pretty steep drop off. Looks like in 2018. So 2018, according to their graph, there are 79, and then 215 and 17, and then very few in 2016. But they acquired ZDI only in 2017, I believe. So that's a very steep drop off. I mean, that could be, as they kind of mentioned, there's the possibility they've just bought all the bugs, but that seems unlikely. So that's why they're now introducing this incentive program to try and get more bugs for their own products.
I do wonder if it's just like, it'd be, obviously they probably don't have it in this report, but it'd be interesting to see how many people actually still use some of those Trend Micro products, because obviously this is an anecdote, but like I haven't heard of anyone using any of these products. I obviously don't use these products.
Well, it's going to be at the more enterprise level anyhow.
Yeah,
not.
I suppose. But like I haven't seen like anything about those products, so I'm wondering if it's just about the popularity of the products themselves dropping, so it's become less of an interesting target.
I don't know if they've had that much of a drop though to only have one issue reported.
That's true. I don't know.
Like, that's significant. Like if it were just a handful, but just one, raises some questions as to whether or not maybe they've just found it better to go, black or gray market.
I was gonna say, so you think it's more that they just don't want to report it to ZDI because they think?
I have no idea. That's purely speculation on my part. I mean, I can't.
Speculation. I was just curious, like what you thought it was, because I was thinking more along the lines of it just wasn't an interesting target, and that's why there's not as many reports on it.
I mean, it's likely going to be related to both. I mean, if I have no idea what any Trend Micro stuff would even go for gray market. So I can imagine it's probably kind of on both. There are, better targets, better paying targets. So even if you look at some of their other targeted initiative programs, like in CMS, like Joomla issues go for 25,000, so like 3 times more than what they're offering on some of these Trend Micro stuff.
Nginx 200,000.
Yeah, and like that's starting to push it into like the gray market values too, like for Nginx and stuff. So I don't know. I feel like there's probably an aspect of the reduced popularity and just lacking incentive to do it, especially since it sounds like 7,500 now is up from what they would have been offering.
Yeah, so, if anybody's interested in those bounty programs, you might have found that interesting.
Yeah, it's out there for you, but take it as you will.
So, and Google put out an Android security bulletin for February 2020. They usually do these like every month or so. These, they include a bunch of security fixes. So, not too much to talk about, but, there were quite a few high severity issues fixed in the framework for AOSP, system app vulnerabilities for like local privilege escalation mostly, and then they had some kernel vulnerabilities and Qualcomm issues as well.
Yeah, so, I mean, nothing here is really all that I expect. I mean, was it just one critical, or I guess 2 criticals? I think, or most of them are high, but only a couple criticals. Only really 2 that are. So one of the criticals is an information disclosure. So in terms of what we care about with remote code execution, just 1 critical and then 1 high that were kind of interest to us. One of the high, so Spectre, you did one of the binder exploits on stream before. So I wasn't going to mention this during the podcast at all, but then we kind of looked at, think something's maybe a little bit fishy here. One of the kernel issues I noticed was in the binder driver. And if you end up taking a look at that, its commit date, it's a like 2-line commit or 2-line change, 6 lines comment, so it's like 8 lines total, but only 2 lines of code from 2018. And it was just seems to be coming in now.
It's like 1 year is a pretty long cycle between like a fix and it actually getting committed into the kernel. Now, obviously.
But this is 2 years.
Or 2 years. Yeah.
Like almost 2 years to the date, because it was February 16th, 2018.
Yeah. And the other binder issue that I covered on stream in October, the use after free that I covered, was also 2 years. But that was a little bit different. That wasn't 2 years from the patch. That was 2 years from discovery. Because it was actually found by, I think it was Syscaller, actually. It was found by fuzzing a few years earlier.
This one was found by Syscaller too. You'll notice that the reported by was Sysbot.
Yeah. But like, it's interesting that we've now had 2 issues within 6 months that have taken 2 years to fix from discovery. At least discovery. Which it seems very weird. It kind of gives me the indication that, or I guess it makes me question a little bit how serious Google is about actually getting security fixes into the kernel for Android, considering that, like,
wasn't the other binder one that you did? Wasn't that one? I think it's now been dubbed Bad Binder, but wasn't that also actively exploited, or am I misremembering that?
That one was exploited in the wild. Yeah.
Yeah. So I mean, perhaps part of it just has to do with the complexity of binder. Perhaps there's some reason it kind of has a lower priority, like if they're working on some sort of replacement for it. I feel like I might have heard something like that. That could be why, they hesitate. But like I said, this was a very small change. I mean, perhaps it had a performance thing, but you'll notice it literally just add 2 lines of code.
Yeah, which is just synchronizing CPUs. I mean, what's interesting about Binder is, if I remember correctly, Binder is accessible from sandboxing, from like all the sandbox profiles, which makes it a very powerful bug if you find one in Binder, because you can use it as a sandbox escape. It acts as a sandbox escape and a privilege escalation to kernel all in one. So you would think Binder would be like.
Do you recall what function it was in when you did your write-up?
It was Binder thread release, I think. It was on.
Did you have to deal with? I thought you had to deal with the wake queue though, because I noticed this one's on EP remove wake queue.
Yeah, mine was on a wait queue. It was basically if you called an ioctl to release the thread, it would call this other function release thread that ended up cleaning up the wait queue, I think. But yeah,
Okay,
interestingly,
so
yeah, this one seems to be on a wait queue as well. So seems they're having some issues with wait queues in
might be a
Google.
place to look for some O days.
Yeah. But yeah, like I was saying, like binder is kind of it should be a very critical component. So if there's any fixes made into the upstream kernel, you would think those would be brought into Android straight away because it's such a critical driver that's accessible by everyone. And I don't know. It makes me question Google's security stance a little bit when it comes to Android kernel.
Yeah, like I imagine there is probably some reasonable explanation here that we're just not aware of. But it definitely does seem suspicious. Like I said, I had only meant to just kind of bring up like, hey, another binder issue, and then it's like, oh, and it's 2 years old. Like, what's going on here?
Yeah. So not too much to say on that. I don't know if we'll look into this one too on stream. Could absolutely. But it is this one does seem to be obviously because it's synchronizing, it's a race, so races are a little bit more annoying to work with. So we'll see if
it does mention,
stream.
specifically that's a race between wake up poll and EP remove wait queue.
Yeah. So it could be interesting to look at, but I'm not going to make any promises on that. One article I almost skipped over was the Dangerous Domain Corp going for sale. So
before we go on to that, actually, since we're already talking about Android, we might as well talk about the other exploit that was mentioned in this Android security bulletin, which is the critical Bluetooth vulnerability.
Oh, right. Yeah, you wanted to bring that up.
Yeah, which this is the one I saw being talked about more because this is, Bluetooth externally accessible and just a stupid overflow. Essentially, I'll bring up the diff here. It just calculate the packet length wrong. So it would basically just calculate the length as being too short for what it should be. And it had to do with packet fragmentation here, but basically when it was calculating the packet length, it would just take whatever the partial length was, subtract whatever offset it's at, and that's the length that it would give it. What it should have been doing was also adding its current offset in the packet for like wherever this fragment was in that packet. It didn't do that, so it would always have a length that was, or could end up having a length that was too short, resulting in an overflow. So straightforward issue there. Obviously remotely exploitable. This was kind of the one that I saw talked about a lot more, kind of on social media and stuff, rather than the binder issue.
I looked into this one a little bit more. So it seemed to be like a heap allocated buffer, so it led to like a heap buffer overflow. But what I thought was interesting was apparently this bug was exploitable on Android Oreo 8 and 9, but it's not exploitable on Android 10. So on Android 10, it's only a DOS, but on 8 and 9, it's an or 8 to 9, I guess, it's an RCE. So I was kind of trying to figure out why that was the case. I couldn't really find any solid answer.
So if it's on the heap, it could be some heap hardening that happens on 10.
That's what I was trying to look for any like mitigations added in 10 that would cause that bug to be less of an issue on Android 10. But, like Android 10, the only big thing I found was the shadow call stack, but I don't think that would be a huge issue with the heap.
It could be. I mean, that kind of comes down to your exploit, like the choice you make on how you're going to exploit that heap overflow. Because usually heap overflows, generally speaking, you're getting, right what, where type of issues. Something where, or arbitrary rights, not necessarily arbitrary. There are other options too, but generally speaking, that's what you're getting. Now, I'm not familiar with heap exploits on Android. I'm going to assume Android being Linux-based, we're probably dealing with, PT malloc, which is the default allocator, but I'm not confident to say that. In response to chat, are you talking about bad binder on Android 10? We were talking a little bit about bad binder when we were talking about the binder exploit, which was, just what we were talking about before this. Because Spectre did a on-stream analysis and exploit of that issue. I'm not sure if that was Android 10 or what it was, though.
I did 8.1, I think.
Okay.
But I mean, yeah, it's just that is something that's kind of interesting. So maybe it is actually exploitable on 10 as well. They just couldn't get it to work, so they put it as a DOS because they couldn't confirm it was RCE-able, for lack of a better word, on 10. But yeah, so that was just something that I found kind of interesting there.
Yeah, so you do make a good point actually about them not being able to confirm it's an RC. I feel like they'd probably have done a little bit more digging on that. It could just be that it's mitigation, because a lot of times, obviously, when you've got a crash, you've got a denial of service. Now, can you turn that into an RC is another question to be kind of be answered is, can you turn your crash into an exploit? So there's a chance of that. I feel like they probably would have had more reasoning to downgrade to a DOS, though, rather than just assuming that could be exploited.
Yeah, it's too bad the reference link doesn't have any other information on that, right? I think you already looked at that. Yeah, that was the report you had open. I don't think it mentioned anything about the discrepancies between 8, 9, and 10, so... EOP, escalation of privilege. Yeah, that's what EOP is. I don't like that terminology. I prefer LPE, local privilege escalation, but EOP is like the more, I guess, enterprise terminology for that.
I don't know, actually. I mean, that's kind of a bit of a side topic, but I think that just has to do with some internal policies, like internal setups, because LPs definitely use, on enterprise level stuff too. Like, it's not...
I just tend to see, if I see EOP, it's more like Microsoft and Google classifications. So I just assumed it was more of like an enterprise term, I guess. I don't know.
Fair enough. Actually, now that since you mentioned Microsoft has that, is it Stride? Is that? I want to say, yeah, Stride, and that uses elevation of privilege.
Okay.
So yeah, I guess if you're using Stride, you're using elevation of privilege. And Stride is fairly, enterprisey.
Yeah, but I'll cap off that discussion by saying LPE over EOP.
I think LPE makes
more
is
more accurate, I guess.
Yeah, more precise in its language.
Yeah,
it's more clear what's going on.
Yeah. So the Dangerous Domain Corp. This was a Krebs on Security article. And it talks about a domain, which is corp.com, which is now going on for sale. So
or 1.7 million if you want it. If you want that corp.com email.
If you have any, like, I don't know, people with very large pockets in our listeners, you can buy it. But yeah, this guy, Mike O'Connor, he seems to be one of those squatters, that just bought up a bunch of domains back when .com was new. He bought like grill.com, place.com, and corp.com. But the problem with corp.com is Microsoft, I think some of their earlier products like Windows Server 2000, I think, ends up using that domain for a lot of internal stuff. And at the time, it wasn't really an issue because, those systems weren't really connected to the wide internet, so they could use that domain and it was fine. But now, where systems most of the time are connected to the internet, they end up trying to forward data to that corp.com domain. And since this guy has had it,
can I kind of jump in there?
Much of an issue. But yeah, you can go on and jump
yeah, well, I just want to jump in and kind of explain where corp.com... So there's also corporate.com, which he owned, which he did something, I think, kind of funny with. But speaking of corporate, it comes down to how Windows will go ahead and try and resolve a domain. As Spectre was saying, it didn't really matter when you're kind of on like this isolated network. But corp.com was basically the default thing that it would just append. So, trying to think here if I've got anything on my network. So if I tried to go to my cloud EX2 Ultra, which happens to be my NAS, try HTTP, it'll kind of automatically try and resolve what actual domain I want it to go to. So I can just type that in and not type in like, my NAS name, whatever internal domain I'm using. It'll just kind of figure that out. Mm-hmm. So corp.com was basically the default that would get used. And with that default as a default, so if you have like mail, so the classic example would be like your payroll website, you might type in just slash or go to payroll and it'll automatically find it on the internal network. If you're in like an enterprise, or your mail server might just be at mail dot the internal domain. So corp.com was the default domain. So if you happened to leave that as the default, and now that it'll resolve online and actually come to this website, it might try and use the mail.corp.com, which is actually owned by this guy. Or, whatever, company.corp.com or whatever. Basically, there's a lot of things misconfigured using the default domain that'll work because it's only, it's looking at the internal DNS and stuff, but it can, in some cases, go ahead and resolve to the corporate, or go and resolve to corp.com when you say take your work laptop and use it on the Starbucks Wi-Fi. It's not going to have the DNS entry for those things like your company one might, or your company VPN might give you. So that's kind of where the core of this comes down to, just in how Microsoft chose to handle domains that didn't have a actual domain appended to them. It would just assume, or by default, do corp.com. That can be changed, but that was kind of the default. I kind of mentioned corporate.com also. Which I thought was in...
I didn't remember it being mentioned in there, so that's why I was kind of wondering what you were meaning when you brought that up.
Well, it was... this guy owned corporate.com, and... unless they've just removed it from here now. But essentially, he had corporate.com, which, if you remember Front Page, Microsoft Front Page was used to build websites, and you could set up to also deploy your website. Just click and it'll upload your website. And the default domain that it would use was corporate.com. So he had that just redirecting off to a local sex store.
Awesome.
So anybody that, used that would...
So probably not a domain we want to bring up on the stream.
Yeah, actually, it does mention here, O'Connor briefly redirecting queries for the domain to the website of a local adult sex toys shop as a joke. He soon got angry emails from confused people who also CC'd Microsoft's co-founder, Bill Gates.
That's pretty funny. But yeah, so obviously, with this domain going up for sale, malicious entities could buy that domain, and any passwords or data, anything that's sent there, they could kind of collect. And they did do years of testing and shows that there is a lot of data that ends up going there by mistake. So there's a bit of a worry with that. So the obvious solution is either don't sell it or sell it to an entity that's trusted. Some people were saying why not sell it directly to Microsoft.
Microsoft obviously doesn't want to pay this. I'd find it hard to believe that he hasn't already reached out to Microsoft and been ignored.
So they actually mentioned that.
Okay.
They mentioned that he did actually reach out to, or Microsoft reached out to him a few years ago, but they were only willing to pay $20,000 for the domain. So, that's why he's not selling.
it is a little bit of extortion here. Pay me $1.7 million, or I release this to malicious actors.
Yeah, so the other reason he gives for not selling it to Microsoft is he says that they should stand up and shoulder the burden of the mistake they made by making the default configuration use the corp.com. I don't really know if that's fair. This kind of seems like it sucks for all parties type situation, because I can understand this guy, I think they said he's 70. He wants to sell the domain, and I don't think it's fair to tell him you can't sell this domain just because it's used by certain things. I think that's kind of a bad precedent, I guess. But I don't know. Should Microsoft really be responsible for this? Is that fair?
No. Microsoft isn't responsible for it. Microsoft's responsible for the default. The sysadmins are responsible for using insecure defaults. Now, I do think Microsoft obviously should have sane defaults, and maybe shouldn't use a TLD that's actually going to resolve. Shouldn't do actually .com, for example. Use some other domain or use some other TLD like .dev. Except then the GTLDs came out, which Google claimed .dev, but using one of the reserved TLDs would have been a wiser move there. That said, I mean to put the fault on Microsoft is essentially victim blaming. It's going if somebody uses this to attack anybody, it's going to be the attacker's fault. I wouldn't just go and blame Microsoft for it. I do think that companies you change default it's a stupid mistake for the company to make. Obviously, I do think Microsoft should have had more sane default set off, but
it's on you to kind of make sure your system's secure and figure it so that it's safe. So I can kind of see that angle. That being said,
yeah, I mean, we could have a much longer debate on that, though.
I mean, one thing I wanted to say, though, is $1.7 million for Microsoft. Let's be honest, that's pocket change. That's nothing.
It isn't a lot of money compared to what Microsoft's making. It's probably a fair bit of money for the guy trying to extort them for it, though.
It is, but what I was going to get to was this could have Microsoft could have used this for really good PR. $1.7 million in the context of how much they actually have is nothing. So it wouldn't have really been a big expense for them in context.
No, but you could look at it like kidnapping. I mean, when you pay the ransom, that just encourages more people to go and do that. More people to ask, should Microsoft also buy, if there are any of the bit squatters, should they buy them out also?
I don't know. I
just this isn't that different from bit squatting.
I just feel like in this case, Microsoft could have came out looking like the hero, and it would have been a really solid PR move that was kind of a missed opportunity. But I do kind of see what you're saying with not wanting to enforce that. It's kind of like the don't pay ransomware thing to not encourage
Although the FBI does encourage you pay ransomware, but to some extent. So I was more thinking ransom on people, not ransomware. Ransomware is an interesting middle ground of sorts when it comes to that.
What do you mean?
So that might be more of a discussion that we want to get into.
I know.
Ransomware, generally, you pay the ransom and they do actually decrypt your data. It's not like you're paying the ransom and they maybe will, maybe won't. Generally speaking, ransomware does pay, and that's why even the FBI now just encourages you to go ahead and pay it, because they're probably not going to be able to get your data back otherwise. Whereas with actual ransoms, they still might kill whoever they've got kidnapped or whatever. There's a lot more that goes into paying an actual a ransom on a person versus ransomware.
Okay.
So while I get paying the ransomware is still kind of encouraging it, your stakes are a lot lower.
Okay, fair enough.
Although I guess, to be fair, you can kind of turn this on me and mention, corp.com. The stakes aren't life or death there either.
No, and I think it's fair to assume he will actually sell it for that price. Comparing it to your example, I don't think he's gonna sell it to somebody
I don't
else,
think that's the
the
issue, but it encourages other people to start doing the same. Like I mentioned, the bit squatters.
But you could say this case is a little bit different from that because it is a default that was done by Microsoft. Not saying necessarily that Microsoft should shoulder all the blame for this, like we were talking about earlier. But, I mean, it's kind of complicated. I would say that I think it would be fair for Microsoft to pay for it, and I don't think it would really encourage the...
I don't think 1.7 million is fair.
1.7 million is a lot. I mean, yeah, that is...
I mean, if somebody wants to do the right thing, it's you give it to Microsoft. Maybe, charge them the costs of running it for so long. So $10 times however many years he's had it for.
Especially considering they did actually offer him 20 grand, which is a lot. it's not a lot compared to 1.7 million, but 1.7 million is also pretty unreasonable. So I mean, 20, like, it's not even like he would have had to give it away for free. He would have been able to sell it for 20 grand, which is a lot for a domain.
Well,
So
no, I mean, going back to, like mentioned, he had like bars, cafes, grill.com, television.com. I mean, at the .com, like during the bubble, those would have gone for quite a bit of money. Like, people were, becoming millionaires over domains that they owned.
what about nowadays, though? Like,
and I mean, it's a 4-letter com. Like, its actual value in terms of just being sold is easily more than 20,000, just because it's a 4-letter.
Okay.
Well, actually, I can't actually say that. I mean, 3-letter and 2-letter for sure. 4-letter, maybe not, actually. I mean, I don't know if there are any 4-letter domains even remaining for com. But I'm not quite as sure about valuation on that. Either way, I do feel like 1.7 million is still high. Like, if you want to do the right thing, you just give it to them. He's trying to figure out how much money he can actually get from it. And so in which case, selling it to the highest bidder is probably what he should do.
So you think the Mike O'Connor guy is kind of the bad guy of the story? You think the article's unfairly painting Microsoft here?
I can understand him. I think he's taking advantage of the position he found himself in, yeah.
Okay.
I mean, I don't think he went out there intending to buy Corp and realizing this would happen. Like, I don't think he was acting maliciously.
No, I don't think he was doing that. But I will be honest. I think, like, after you gave your point of view, I think I'm aligning a little bit more to what you're saying. At first, I was thinking, it's absolutely fair that he wants to sell it, but it is kind of like extortion. So yeah, I kind of side with you on that one.
No, he's fair to sell it. Like, I don't think he's doing anything wrong by selling it. It's completely legal for him to sell it. If some malicious actor wants to start abusing it, abusing it probably isn't legal, but buying the domain, it's just a domain. Microsoft has the ability to kind of take steps to prevent it from being exploited by changing that default.
Yeah.
But I do think this is kind of painting Microsoft as a bit more of the bad guy than I think is fair.
So NordVPN is back in the show.
Yeah, it's been a little while
since
we talked about them.
It's not for a cert issue this time, but it's for a HackerOne bounty that was publicly opened up last week. So the issue...
Yeah, so I'll actually really quickly mention that NordVPN, in response actually to... so we talked about back in December about NordVPN, one of their certificates being leaked. The private key for one of their older certs was leaked. There was a lot of drama over exactly what happened. But in response to that, NordVPN did start off a HackerOne bug bounty. So this actually... If you take a look at NordVPN here, if you look up, this just started on December 2019. So this is pretty much in response to that last issue. And I do want to mention, we're talking about Nord. This issue, I'll let you decide whether or not you think it's a big deal. Okay. That said, I will just say I think it's important to consider the response Nord had to the last issue that's been brought up on the show, which is, they've opened up the bug bounty, they've started more auditing, a more detailed audit. They've taken a lot of the right steps in response to a significant security incident. So, I can't really fault them for that. I think it's always important to look at not just, what issues the company's had, but how they've responded to that. And I think I'd say Nord has responded appropriately.
It's fair to give credit for that, yeah.
Yeah,
so I think that's,
and that said, personally, I thought this issue was actually a bigger deal than they were making out to. So they paid $1,000 as the bounty on this. They put it as kind of high. I think $1,000 was their low payout for... criticals, though. I think so. Either way, so when I saw this, essentially all was with your payments. It's an insecure direct object reference, so you've kind of got your request in there, the post request, and in there it has a user ID. Increment the user ID by 1, and you get another user's information. Leaks email, which seems to be the most serious thing in here. That said, what I saw initially was the success URL and the cancel URL. My initial thought, and I saw those were callbacks with a random ID, was that this was the IPN or instant payment notification callback URL. So then somebody could drop this, get whatever the success URL was, make the call to that themselves and fake a payment. That's not the case. It's not the IPN URL. It's just where the IPN will actually redirect them to. So it's not that significant. But when I initially added it, I thought it might have been that. That said, I mean, email is still kind of significant, and with the fact that somebody in this case is using coin payments. They're probably trying to stay somewhat anonymous with this.
Yeah.
And here's their email, and you can just dump all their email, like a bunch of users' emails with this.
Yeah. So, I mean, you were kind of talking about NordVPN's security stance and how it's kind of improved. And one thing I was kind of impressed with this report is it was reported on December 4th, and it was fixed by December 6th. It was fixed in 2 days. So they took it seriously. They fixed it. It was kind of a silly issue, but they fixed it pretty fast. And they paid out $1,000. I think that's a fair payout. I don't think they're lowballing or anything like that. I think this is a good strong case in Nord's favor, I think.
Yeah, so do I. That said, I will mention, since you mentioned the fix time, there was another issue that was disclosed this week also, just a couple of days ago, which had a little bit more of a back and forth. So it was no rate limit on the forgot password page of NordVPN. They paid out $500 for it. But saving you a bit here, they basically initially on December 6th rejected it as simply being informative and not an actual issue. So their statement was, well, our front end always shows the same message, but the back end won't actually be sending the email, so it's a non-issue. So they essentially went, closing as informative on December 6th, and then they respond back, can you try again and make sure? And if eventually they do actually end up fixing it, they gave it to Medium, and they actually did fix it still reasonably quickly. But there was that back and forth where they initially rejected a valid finding as being invalid. That said, like I said, they did respond to it. He continued to just show, no, this actually, your server isn't actually rate limiting this like you think it is. Gave some evidence. They responded to that. They didn't just ignore them. So, that's good. But since you brought that up, I figured I'd mention there was one other issue paid out.
Yeah. Overall, still a net positive, though.
For sure. I mean, any company starting to have a bounty is a net positive. Well, I've said before, I'm all for companies being able to decide for themselves whether or not to have a bounty. I think a good sign is when a company does have a bounty. Or a bounty program, I should say.
Yeah. And another HackerOne report was hacking Twitter. Getting into one of our title, our headline news pieces.
Yeah, unfortunately, you're not really going to, compromise all of Twitter with this.
Especially
this is one
anymore.
of those. Yeah, now that's fixed too.
Yeah.
This is one of those kind of defense in depth things. So one thing that Twitter does is, when you go to change your, I think it's specifically email and phone numbers. So you're logged in already and you want to change your email, you want to change your phone number. It'll ask you to enter your password before it lets you do either of those actions. It just pops up the little box, enter your password, submit that, pops up another box assuming you have the password correct with the whatever information you want to change, the form to do that. So the idea there being, if somebody were to hijack your session or somehow gain control of your account, they could actually change those things without also knowing your password. There are, of course, plenty of ways your account could be compromised and the password compromised, but there's a lot more ways where the compromise would not be able to know your password. So in this case, essentially what was discovered was if you made the request to change So if you go through, you have to get a flow ID. So you go through the normal flow where it asks for your password. Even if you enter the wrong password, though, if you just make the request for the next part of it to change your email, to change your phone number, it'll effectively just accept it because you gave it a valid flow ID. It won't care about the fact that you didn't actually properly go through the entire flow, allowing you to change the change the email or change the phone number without actually knowing the password. It's reasonably common whenever you see these multi-stage flows to go through. Trying to access flows in the wrong order is a good trick to try, because it definitely happens quite frequently where the flow validation won't be checked correctly, or it'll just make assumptions that you've already done something. I think we've talked about other issues. I think we talked about a 2FA bypass that was effectively you just ignored the 2FA flow and kept going. I don't remember what that was on, but I feel like we've talked about a very similar issue before. And it's definitely something I've seen in a number of places before.
So the big issue with this and why it's important is because, obviously your email and your phone number are like the most common methods for password recovery. So being able to change that is a pretty critical function. So that's why they have it behind that, defense in depth, like you were talking about. So, that is a really good target to hit if you did do like a session hijack, because then you could just, if you needed the password or you wanted to take
that's
over
how
the
you
account entirely, you just
that's how you get your
recovery
foothold or your persistence afterwards. Is you do the session hijack, you change the email, go through the email recovery flow, and now you've got the whole account.
So they listed it as a high severity, 7.8.9, and they paid out a $700 bounty for it. And this was another issue that it seemed it was taken seriously right off the get go, and it was fixed fairly fast. I think it was fixed within a month. It wasn't quite as fast as the previous ones we talked about, but still pretty quick. And they asked, could we disclose it? And then they're like, yeah. So, and I think that's cool too. I think that's something that's worth pointing out on some of these reports. Is one thing I've noticed with HackerOne in the past is not all reports go public. Some just stay private forever. They're just permanently blacked out. It's up to the vendor if they want to disclose the report, which I think you're in support of. We talked a little bit about that before.
Yeah, I'm in support of vendors choosing to disclose it. I do think they should kind of get that choice, but yeah. I do think like a positive sign is a vendor that's very open about their security policies, having the bounty and all of that. Like, it's a very positive sign for them to do that.
I think it's worth giving credit for these companies even making some of these reports public, because I have noticed, especially with some of the bigger companies, that sometimes they never want to publicize reports. They're just like, okay, thanks for the report, we fixed it, we'll put it in this lockbox and never talk about it again. So, I think we're starting to see more of these like open reports, and I think that's a good sign. I just wanted to, highlight that. Because that is something, if you haven't looked at HackerOne, it's not always commonplace that these reports are open. So, yeah, did just want to point that out. So a critical flaw in WhatsApp. We talked about WhatsApp before, and it's kind of creeped back in. So this was an article by Gal Wiseman, I think is how you say it, from Perimeter. And he talks about some vulnerabilities found in WhatsApp. So we found multiple issues. I think he found like 5 issues. So, and they all kind of chained together, which I thought was really cool. So the first flaw he found was that in WhatsApp, you can actually modify quoted messages in replies. So, if you go to reply to a message, it'll quote the message that you're replying to, and then you write your reply. And in the web UI, you can't change that quoted message for obvious reasons. The only reason you'd want to do that is if you were doing it disingenuously. But you can actually change it through, like, I think you can just change it directly in the reply text.
Yeah, so, well, the idea is that the message itself is all composed locally. So you can change whatever you want about that. I mean, it's similar on Discord. You like that's very similar, not necessarily issue, because Discord doesn't do like replying like WhatsApp does, but the embed messages, which is where this thing will get to, are also that's user controlled. You can put anything you want in them, even though by default it's just going to fill in kind of what the URL information is. But I'll let you get back to explaining it. or I'll keep talking.
Sorry, I just got a weird cutout. I think my internet just had an issue because the stream
Okay,
cut out for me too. Sorry, but yeah, sorry. Can you just repeat like the last sentence of what you were saying? Because I missed it.
So I was just mentioning that this is a similar issue like on Discord where you can control the content of the embeds, where you do like you put a URL in and then it fills in like the embedded information about that website, like an image or a description or something of that nature. Yeah, that's just user controlled. So it's kind of the same deal with these quotes in WhatsApp. They're all just user controlled. So a user can control whatever data is there. Like it's all crafted locally. It's not the server creating those replies or creating that sort of special message.
Yeah. So that issue itself, it's more of like a prank bug, right? And so he didn't really do much with it. He just kind of, used it on a few friends and then forgot about it. A few months later, I think he noted that it was found and published by Checkpoint. So, small issue, but nothing too serious. But some of the other issues start to get more serious. And the second issue that he found was an open redirect flaw in rich preview banners.
See, and I don't know if I'd call this open redirect.
Okay.
It's an old... So I guess I'll talk really quickly on what it was. Effectively, what he found was just the old school. If you include authentication information in a URL, it'll look like the URL belongs to one domain, but it actually goes to another. So by authentication information, I just mean when you include that @ sign in your URL. So if you've ever kind of viewed a website that when you first visit it, it'll say something like it'll have like a little pop-up, almost like an alert pop-up with a couple input boxes that'll be like HTTP basic auth and then username password. You can actually supply that information as part of your URL by doing username : and then your password @ and then the whole website, and that just goes in there as part of your HTTP auth, like the authorization header or whatever. So a common trick that's been around, years and years. I mean, I remember this being around when I was a kid, was to craft a URL that looks like it goes, facebook.com in this case, and then just toss that little @ at the end and put the actual URL, where nobody's going to notice it. So that's what this open redirect was in this case, in the example on screen, it's facebook.com plus login, blah, 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 @ bit.ly or bit.ly / the actual URL. I wouldn't say that's an open redirect because it shows the actual URL and it's going to the URL that it should be going to.
It's just not very noticeable.
It's a phishing trick. That's what it is. This is something you should be aware of just in terms of phishing. That said, modern Chrome, they mention this, does warn you about seeing these URLs, but we'll mention more on that later. I'm quite certain that Firefox will warn you about it, but I forgot to actually double check that. But like, this is a really old trick that's been used for a long time. It's not really open redirect. Nothing's redirecting you to a page it shouldn't. More likely is that if you're writing a web app, just don't allow, ats in the URL without reason to actually do that. Because I mean, that's not something most websites need these days. That was more common when it's like you'd link to FTP or something.
Yeah, FTP is the most common use case for it. I just want to point out from chat, from some dude 456, no V8 exploitation. I'll get around to mentioning that actually at the end of the episode, because I do have something to say on that, but I don't want to go off track with our topics. So yeah, just wanted to say that really quick. Sorry, did you want to add anything on there with the open redirect, or what you don't like about it being called an open redirect?
Well, I think I've kind of established why I don't think it's actually an open redirect.
Okay. Yeah, I just didn't know if you had anything else to add on to your...
No, not really.
It's okay.
If you want to keep going.
Okay. So the third issue used this open redirect in quotations to keep Zai happy. But instead of putting a link, he actually managed to get JavaScript working when you click the banner image, which would lead to persistent XSS. So he used a bit of a trick here. He basically made it so that he tried basically a simple XSS, JavaScript alert, and it didn't work. But he checked if it expected a legitimate HTTPS scheme. So he just put one in there, and then he used a semicolon to put an alert, and it worked. So he found an XSS in that same component that we were talking about. So he does mention that Chrome-based browsers added a defense against those URIs, but it can be abused in other browsers like Firefox and Edge and stuff like that. But this is where we kind of get into some more serious issues. Persistent XSS is more serious than the other two issues we covered.
Although, to be fair, this does require clicking on the XSS link.
Yeah, that's a good point. And
it does look kind of suspicious.
A little bit, yeah. The fourth issue is utilizing the CSP evaluator, which Google has, to try to bypass the CSP rules in order to make that persistent XSS more powerful. And CSP is content security policy. So
yeah, basically they just didn't have a CSP rule set for object source, which allowed them basically to inject objects that would have whatever HTML he wanted and could interact with like window.top as he does, and start loading other external content that way. Yeah. He used the CSP evaluator just to figure out that they were missing a requirement on there.
Yeah. And then the fifth issue is kind of the cherry on the cake. It talks about what you could actually do when you chain these bugs together. So what he talks about is WhatsApp basically uses Electron. People listening have probably heard of Electron before. It's basically a way to make desktop apps that are pretty much web apps, let's be honest. And Electron used Chrome 69. Chrome 69 is quite old. I think we're up to like Chrome 81 or something like that now. We're pretty high now. So 69, that's quite an old version. So the problem with that is once you start being able to run arbitrary JavaScript on, a victim's machine, and you're on an outdated browser like that, it makes it a lot easier to pull off end-day attacks. So if you have a Chrome end-day browser exploit, Chrome 69, you're probably going to be able to hit with any recent, end day that might have been dropped within the last, I don't know, I want to say 8 months at least. So it's a pretty big window for end day attacks. So that's one issue. And obviously, if somebody exploits something like that, they could get an RCE on you. Browser's a pretty common entry point for RCE attacks. But he didn't try exploiting an RCE, but he did manage to pull files off the target system using the Fetch API. So he's just kind of demonstrating what kind of issues you could have when you have that JavaScript, being able to execute arbitrary JavaScript, which you get through that XSS. So I thought it was pretty cool that he kind of chained the issues together to show how you can actually pull off a practical attack. I think that's something that's sometimes missing from these kinds of write-ups. But yeah, so this XSS, it's been patched by Facebook. But I think this kind of highlights why people in the security community aren't really happy with the direction of everything using Electron is issues like this. If you have an Electron version that has an outdated browser version bundled with it, one XSS can lead to RCE fairly easily because of the outdated version. And I think that's kind of the big sticking point of the article for me.
Yeah, I mean, that's definitely a key point, is keeping the Chrome version up to date. I mean, Electron uses Chrome. There are other options, if you want to embed in, the Firefox engine or whatever. Generally speaking, that's just not done, but options do exist that aren't Chrome, but Electron is kind of your most common thing. And yeah, I mean, it just kind of separates them because it now becomes an extra step to always update the browser and update everything that your code's using. And yeah, it creates desktop applications that are vulnerable to things like cross-site scripting, where they weren't for most of the lifetime of desktop applications. Haven't been vulnerable to cross-site scripting, because why would you do that?
Yeah.
And of course, in this case, cross-site scripting also leads to much more serious issues because you do just have access to fetch, you have access to the file system or whatever other APIs there might be.
Yeah. I mean, it's a lot more likely for you to keep your browser up to date than it is to keep your like Electron version up to date. One thing I kind of wonder is like, is there an actual reason why things like Electron don't use the system installed Chrome as their base? Is there a reason they can't do that? Because I feel like that would be...
Is there a system installed Chrome? What version is it? I mean, part of the benefit of using Electron is the consistency. You write one application, and it can be deployed on the web. It can be deployed as a mobile application on iOS, on Android, on BlackBerry, I don't know, on Windows Phone. It can be deployed in your browser. It can be deployed as a desktop application, all with one code base. So the browser changes, little things change all the time. So most people aren't going to want to support, 20 different browsers. They're going to support the one browser that's kind of built in to their Electron application.
Yeah, I mean,
so,
I guess
so that's why it's the convenience.
It is the convenience, but like, I'm just thinking, like, I know in consoles, for example, there are games and stuff that use the browser, and they don't bundle in their own browser. They use the one that's on the system. So
consoles are a pretty special environment, though.
Yeah, I know. I'm just trying to like see if that could be pulled into other environments, though. Because
I mean, could it? Yes, but will it? No. I mean, the whole point of Electron is the fact that you don't have to do all of the feature detection or anything like that. You can just write your one code base and it's going to work. As soon as you start doing that, you're back to where you were before, needing to detect what features this browser has, what browser is it, and what you're going to do with that.
Yeah, it's one of those security versus convenience issues, I guess. Yeah, I mean, we're
at the same time, I mean, you can argue that by having a static version, you know that your code isn't, like, there's no vulnerabilities that are going to be introduced because of a new feature in the browser coming in. Like, it does go both ways. By fixing your code base, like, nothing's changing.
Yeah, that's a decent point. I mean, obviously, we can talk about it, but it's like, it's not going to stop. The adoption of Electron has just kind of been growing more and more. I think eventually all of our desktop apps are going to be, you're going to have IDA and it's going to be Electron based. But like, yeah, it is one of those things where it's, this is a good highlight of some of the security issues that do come with that. But yeah, overall, I really like the article. It kind of went into that practical aspect and chaining them together. So I thought that was cool.
Yeah.
CDPwn. So we talked about Cisco before, and we're going to talk about him again. So there was a research company named Armis. I think it's Armis. I don't know how to... I'm going to assume I'm pronouncing it right. So they put out an article on 5 critical vulnerabilities they found in the Cisco Discovery Protocol, or CDP, which is why they named their article CDPwn. So CDP, as I understand it, is basically like a data link layer protocol for communicating with local Cisco devices. So there were multiple vulnerabilities found. Almost all of them are like really trivial issues that are, low-hanging fruit. Is like the, coin term that we like to use for these types of issues. So the first vulnerability was a stack overflow in how they handle power over Ethernet, PoE, in the NX OS for network switches. I think that one's for network switches. So yeah, there was a stack overflow when handling those. The second vulnerability was a format string vulnerability in a very similar area. Yeah, go ahead.
Well, I mean, we can mention a bit more details here. So the first one was, so TLV is kind of a little term used throughout all of this. All that is, so when we mentioned kind of the different TLV, table length value. It's just kind of like the formatting this tends to use through like all of the Cisco Discovery Protocol is, you give it the type, you give it the length, you give it the value. You'll notice, actually, I've brought up on screen the white paper for this. You've got type, address, length, 17. And then they've got the value for the IP address. They also have a number of addresses, but essentially things just follow this one format. So in the addresses TLV, as you can see, there's that number that's included, number of addresses. What happens in the code is it I don't, for some reason I don't have, right, so number of addresses is 4 bytes long, so you can have 4 bytes, so what, 4, that's like 4 billion or whatever, I want to say, 32-bit. Whatever your max is, like you can have a huge amount of addresses listed there. But it copies it into I believe it copies it into a fixed size buffer. Some of my notes seem to have disappeared on me. Okay, no, it's not. This one wasn't an overflow. This was just resource exhaustion. My bad there. So the first one here, basically, if you made a bunch of requests with, for 4 billion bytes, it's just going to allocate that, and then you make send another packet doing exactly the same thing, and eventually it runs out of memory and it crashes. Crashes again. After a few crashes, the device will reboot. So it's a denial of service.
Yeah.
The Stack Overflow was the second one covered in the white paper.
So I don't have the white paper open on my screen, so maybe I don't know if you want to kind of take over a little bit on that one, because I don't have it open.
I was going to.
Okay.
So yeah, the next one was in the Power Request TLV, which is, okay, so that's the one you were talking about with Power over Ethernet, which is a really straightforward, stupid, like it's something that should be detected when even fuzzing. But essentially all it is the list length. And we'll pull up their code that they have here. It's not the one. Or maybe I won't, but anyway, the list length was you can once again give it like how many entries basically. It copies it into a fixed sized buffer that is takes like the maximum of 16 bits worth, so like 65.535 I want to say. Don't ask me why I know that particular power of 2, but that's one I know. If you send it a list that's greater in size, it's just going to keep writing along the stack as you would expect and overflow and smash the stack. No canaries. Does have ASLR, but it's only a 32-bit system, so you can brute force it. Being 32 bits, it's like only the 1 byte, only like the highest byte actually gets changed, or the most significant byte actually gets changed in the ASLR, so there is the chance for brute force. Might be a little bit loud if the device needs to reboot every time it fails, but it's not that impractical to just brute force that. So the third issue is in iOS, and I will just mention they've got NXOS, which makes me think of the Nintendo Switch, and now iOS, which makes me think, and obviously they had NX and iOS before the Switch and before the iOS devices, but it's just an interesting thing that they actually, I don't know where I'm going with that. So the next issue was the format string vulnerability. Effectively, device IDs, port IDs, software version, and like the announcements that neighbors would send to say like, hey, I'm a device on your network, I'm near you. You gave it a device ID or port ID with format string bit or like a formatter in it. There you go with your format string vulnerability. And why aren't these issues dead already? I mean, format string issues are one of those things that should be picked up by most scanners. Like, I don't know.
I was gonna say, like, all of these issues look like they could be found by dumb fuzzing. You wouldn't even need smart fuzzing. Like,
so the format string, I don't know what the case was to get the string actually rendered. So I could see there being a little bit more that wouldn't necessarily get picked up with the dumb fuzzer, especially since the dumb fuzzer would also need to do like, a particular format. But the other ones though, like absolutely just standard random fuzzing should have picked these up. Like any sort of proper testing should have picked it up.
Yeah. The other thing I was going to say was I think there were 2 or 3 issues I think that were related to power over Ethernet. And I feel like we've talked about power over Ethernet before in the context of vulnerabilities. Why
Maybe
is it so
another
hard to get
Cisco
that
one?
right? Maybe it was another Cisco one, but it's like
I don't remember what the other issues were, so I can't comment on that.
yeah, I just like over Ethernet seems like it should be something that's fairly simple, but it's like it seems like it's been really hard, at least for Cisco, to get it right.
I mean, this one just happens to be in the power over Ethernet, but like the actual issue is just the fact that you can send it a longer list than it's expecting. Like, I mean, it's not really related to anything special about power over Ethernet.
No, it's just that area does seem to have,
like I said, I don't remember the other ones, so
yeah, fair enough.
I can't comment there. But so all of these issues that we've just talked about, the three of them, are in a lot of the Cisco routers and switches. So we've mentioned it's on iOS, it's on NX. That's your switches and your routers. There are some issues, however, in their phones and their cameras. In their IP phones and IP cameras, of course. Which is two more issues. Again, another stack overflow in the port ID TLV, which isn't checked against the buffer size, so literally just copies it in. It has a fixed size buffer, copies it, and just does the memory copy right over for it. Nothing
I'm just
special
looking
there.
At that code, and I can already see looking at that code, I can already guess that their fix might not even be good enough. Just seeing like len -4 and b10 +4 directly in the source and destination arguments for memcopy, it makes me wonder if even if they do fix it, there's probably going to be like an integer overflow that you can then use to overflow it again post fix. So it might be worth looking at these again even after they fix them.
Yeah, perhaps. I'm not sure if these are fixed yet. And then the last issue, finally, is with the device ID TLV. There's a heap overflow.
Lots of overflows.
Yeah, so, I mean, it's kind of the same deal. In this case, they've got the value length, they've got an allocation length. Allocation length is just 1 byte. The value length is up to 2 bytes. So we'll do the allocation of up to 1 byte in data, or allocation length, and then if you can give it up to 2 bytes for the actual size that's going to copy over in the memcopy. So it just reads the TLV value length.
How do you even do that?
Yeah,
wow.
I mean, so
that
I'd be kind of interested to see. Well, so the thing to keep in mind, the code that we're seeing isn't the actual code, of course. This is reverse engineered code.
Oh, no, I know, but still, like, using two different, like, completely different types for the value length and the allocation length. Like, oh, wow.
Well, because it's just trying to copy over the data it needs, apparently.
Okay.
I mean,
that's weird, man.
But it's, like, at the 1 byte level, I agree, it's weird.
Yeah.
So, but it looks more weird in this case, I think, because we see kind of those two declarations for the case for the device ID just right there in the code. Whereas I think in practice, those might be allocated elsewhere or something that we're not quite seeing. That would have made it a little bit less obvious.
Yeah. So I kind of wanted to call out the article. Well, not call it out in a bad way, call it in a good way. One thing that I thought was cool was they actually had on their, not on the white paper, but on their webpage, they had a video demonstrating each issue. And I thought that was pretty cool that they had like a little video demo for each issue.
Well, they've made it almost a named vuln, or it is a named vuln, so.
Yeah, CDPwn, yeah. But I mean, it's a really thorough page.
It didn't get its own domain, though, so that's why I only said almost a named vuln.
It's not quite at that hype level. That's not at the hype train level.
Yeah, one thing I will quickly mention there with the very last one, that was in their IP cameras. It is a heap overflow, which does make exploitation a little bit different. Obviously, it runs Linux, so I'm going to assume PT malloc. So trying to exploit it sounds like, you'd have to do a little bit of, feng shui to maybe get the right data next to it and stack and overwrite like some useful data rather than necessarily getting control of code execution directly. And usually, like if you are going to do something that's dealing with the heap metadata, usually you're going to need a free or something, which I assume they can easily cause, but it's not mentioned here explicitly. So there might be some kind of tricks to getting at, but it's not immediately obvious.
Yeah. So there was a presentation given at OWASP Night in Japan, and there were some slides released. Now, you've actually pulled up the webpage, but I was reading through the slides.
Yeah, and I will say the slides are actually better if you want to take a look at this. I do have, or I thought I had the link to the slides here, but apparently I don't.
Lost it?
So yeah, well, so I'll try and have the links in the notes and the description stuff. I'll try and have the link to the slides, because the slides do make it a little bit easier to understand what's going on with this issue. Okay. It has some nicer examples, whereas this blog post is very direct about, here it is. And I'm not entirely certain, neither is the author, entirely certain that this is new, or is a new technique. It's not something I've really heard talked about before. It's also not something I can immediately think of cases where it would have been useful, but so REDOS, regular expression, denial of service. Basically, you cause a denial of service by giving it a regex that's going to take a long time to process. Usually that involves causing backtracing to happen. When it does the greedy matches, it'll try and find all the matches. The main example that they use is nested qualifiers, where you kind of have this dot star star type of structure going on. Mm-hmm. And nested in brackets, so it matches the dot star and it matches a star beside that. And then I think they use, in their actual examples, they do a dot star star star, doing it 3 times there, causing even more kind of backtracking, making it a real pain. But so that's denial of service with the regex. So what they're going for with this is the idea of doing blind regex injection, or being able to extract information about what's being searched without actually being able to see the end results of that search. So similar to the, blind SQL injection, where you just get, the same page no matter what, but you're able to find out or ask the system questions through the regex in this case. So you do need some control of the regex being run, which is reasonably uncommon. Generally speaking, searches aren't going to give you regex or like you run regex, but some do, so it does happen. And it would have to be something where you're not seeing the results of the search, or at least part of those results are being hidden from you.
So it's a highly specific scenario.
Yeah. Although, to be fair, you could kind of say the same thing about, blind SQL injection. It's a very specific thing where you're able to have parts of the SQL query under your control, but you're not seeing the results of it or any results to know if it's successful or not. For time-based, obviously, there's error-based blind SQL injection, where you do kind of get an error, you get some difference based on. But yeah, the gist of it is you're injecting a query if you want to see if some string's present, followed by whatever causes a big timeout, followed by some data that won't be present or that shouldn't be present.
So I mean, he even kind of admits in the presentation that it is more of a CTF type issue. It's
yeah, I mean,
you're going to encounter too often in the real world.
Yeah, like I said, it's not something I've seen but I think being aware of it, maybe I'll pay attention and maybe find a use for it if I'm doing an assessment. It is one of those things that it's not your everyday issue, but it's still an interesting premise. I hadn't even thought about, injecting or pulling any information out from it, but it totally makes sense to do it.
Yeah, so I will say I did kind of look into it, because when he was I'm not sure if this is a new technique, I did kind of do a little bit of research into seeing if I could find anything like that in the past. So I looked into REDOS and stuff like that, and I didn't see anything mentioning using it as an oracle like this.
Yeah, so well, I wouldn't expect it to come up searching for REDOS in particular, because, that denial of service, you're usually not looking at also using that for that. If you were looking it up for the similar issue with SQL injection, you wouldn't look up, some sort of SQL-based denial of service. So, with that said, like I said, I've been around long enough that I feel like I'd have been familiar with it already. So I think
Been
it is
around the block.
definitely possible that it's a new idea.
Yeah. So, he suggests some like courses of action for like, preventing these types of issues, which is not allowing user controllable regular expressions, at least with backtracing based engines, and avoiding some of those anti patterns. So,
All right.
yeah,
And I guess
just
before we switch the topics, I do have the link to the slides here, so I'll pull that up really
cool.
quickly, just so the timestamp gets into our notes. But yeah, the slides are, I think, a lot more clear about kind of how it works if you step through it. It goes into a lot more detail, I think, than the blog does. The blog just kind of assumes you already know a lot of
It
this
breaks you in
background.
better, I think.
Yeah.
Yeah.
Like, I feel like the blog was almost just an afterthought.
Yeah. So, getting into some white papers, we have GhostKnight, which is breaching data integrity via speculative execution. So, we've talked about speculative execution before, where we've kind of taken a bit of a hiatus from it, but we're coming back to it with this paper. So they mentioned some of the previous speculative execution attacks we've seen, like Meltdown and Spectre, which we've talked about before, and obviously I'm pretty sure everyone who's listening has heard of those attacks. And they kind of highlight what they bring new to the table in that area. So, and that's compromising data integrity rather than just the confidentiality through bit flips. So previous attacks like Spectre, you could leak information, but you couldn't really corrupt it like what they're saying their attack can do. So they have
if I
kind
can,
of a...
I'll let you keep going with this, but I figure I'll just say for anybody who's kind of listening, who's wondering there really quickly, Rowhammer via speculative execution is essentially the spoiler for this. That's essentially what's going on, but go ahead.
Yeah, so I was just trying to find the paragraph. It seems my search isn't actually working for some reason. I guess it's because of the font they used or something like that. But they have a really key paragraph. Maybe you can try to search for it while I read it out. But I think it kind of highlights, it kind of summarizes the paper really well. And they give an example case where if there's an index value into an array and it passes like a size check, then they take the branch to perform a valid memory or a valid array access. When the array size resides within DRAM and it takes a few cycles to arrive, the processor will not wait for the check to be resolved. It'll use prediction history to predict whether or not the check will pass. So you can train the branch predictor to basically induce the processor to speculatively perform the memory access to trigger a DRAM access. And that DRAM access is where that Rowhammer type attack kind of comes into play. So there's three main phases to the GhostKnight attack. So the first one is they collect vulnerable addresses. So they scan system memory and they probe for bad rows. And they do that using a tool provided by Google called Rowhammer Test. And it looks for row conflict address pairs. And then using that, they perform the speculative hammering, and they try to mistrain the branch predictor to trigger speculative DRAM accesses. And then they check if any bit flips occurred. If not, they kind of go back to that second stage, and they keep repeating. So the threat model assumes that the attacker can control an unprivileged process, so they have code execution on the target machine, and that the install modules are susceptible to Rowhammer induced by software. So in this paper, they proved that they could actually trigger bit flips via the speculative execution. So this paper, I think they kind of stop there. They kind of demonstrate that they can get the bit flips, but they say that in a future paper, they're going to try to demonstrate utilizing the attack to actually cross privilege barriers to defeat the memory management unit virtualization and stuff like that. So, defeating sandboxing, defeating user kernel space isolation, potentially even hitting secure enclaves, stuff like that. So, like you were saying, this is an attack that kind of marries Rowhammer attacks and speculative execution into one thing. So, it's using that idea of Spectre, which is mistraining the branch predictor, and trying to cause the bit flip on the DRAM access. So yeah, I thought this paper was pretty cool. And, when we're talking about speculative execution, a lot of them kind of just stick to the information leakage, right? They kind of stick to the tried and true. A lot of the attacks are just variants, but this one was different, and that's what I kind of liked about it. It was kind of a breath of fresh air in the speculative execution area, I guess. What are your thoughts on that?
I mean, I agree. It was a different approach to it. It's something new. Obviously, since Spectre and Meltdown came out, we've heard a lot about speculative execution issues. So, I mean, I generally agree with what you said. I can't really add anything to that.
I didn't know if you.
I don't disagree.
Okay, yeah. So yeah, really cool paper. I would recommend, even if you're not familiar with like the low level, you might have to do some additional research, but I would recommend checking this paper out. Considering it's dealing with such a low level issue, I found it to be very accessible. Obviously, Z and I don't really do hardware stuff. We don't really, I've never tried pulling off a row hammer attack, for example, but I found the paper really accessible. So I think it's cool. I think it's worth checking out, and it brings something new to the table. So yeah, we just kind of wanted to highlight that because it's a cool new attack. Maybe we'll see their next paper trying to go into more of the practical applications of it, and we can cover that too in a future show. So another paper we have is brightness, which is leaking sensitive data from air-gapped workstations via screen brightness. So this one, I think we're starting to get more into the fun world. This is kind of like the spy world, I guess, in a way. Exfiltrating
I
data
guess.
from
I don't know how
workstations.
practical this really
Oh,
would
it's
be.
not practical at all.
But
I think it's more of a fun paper.
But at the same time, I was surprised. So you can guess by the name already. You're leaking information by changing the brightness of the pixels on screen and having some sort of device that can capture that and then kind of figure out what data you are exfiltrating. So it would work on air-gapped systems, and we've seen other things like blinking an LED to send information, or using audio to do ultrasonic audio that basically just can't be heard, like the high or low pitch or whatever. So this is just another kind of trick towards that. I was surprised by the one aspect that was it only required them to actually change the brightness. And I will mention, so this is working not so much on like your screen total brightness, but the idea was like a driver that would automatically adjust, the brightness of every pixel, up just a couple percent or down a couple percent for your ones or zeros. So they only need to adjust it about 3% to start, practically getting information out and reliably detecting it. Like 3% isn't really noticeable. If your screen was changing brightness by about that much, like you're not really noticing it. So I did find that interesting. That aspect I think actually could make it maybe practical. The real issue is that in most air-gapped systems, you're also not allowed to like bring in your phone to record the screen. Similarly, you're not going to be sitting there monitoring the security cameras and having your phone on to record whatever's going on. Like generally speaking, air-gapped workstation, a lot of things are going to be air-gapped, so you can't exfil information off of it.
I think more importantly, you're not going to get that initial access on the system to be able to, install that malware that changes the brightness too.
Well, so a lot of this kind of assumes you're able to compromise the device, but now you need to find a way to get information out.
Oh, for sure. But I'm just saying.
I mean, that's a lot of the attacks do that.
That is a lot of the, that is a lot of the battle, so to speak.
Yeah, a lot of the battle is doing that, but you do have to get the information out somehow.
Mm-hmm.
So I think it's practical, or I think it's at least reasonable to start off with that assumption that you've already compromised, and now how do you get the information out? Like I wouldn't say it's not practical because air-gapped systems are already reasonably secure against a lot of attacks just by virtue of being air-gapped. Like that's just kind of a given with air-gapped that you're dealing with that already. It's just, I feel like most cases where I'm familiar with air-gapped systems being used, the camera isn't going to be a feasible way of getting data out.
Yeah. I mean, some of the countermeasures were pretty funny too. I noted their countermeasures were basically isolate sensitive computers and position cameras so that they're not like looking at those sensitive computers. They were kind of funny countermeasures. I just wanted to,
which I mean is a fair thing. Like that is, but I feel like that's also something that's already recommended.
Yeah, I mean, it's one of those things where if you already have camera access and can already install a camera, you probably don't even need the malware, to be honest. Like, you can see what's happening on the screen. Yeah, you might not get, like, passwords or something like that, but, like,
Well,
you
if you've
already
got a
have,
camera, you
like,
can see them typing a password.
not necessarily. There might be something obscuring, like, the keyboard, but you can see the screen. I mean, if you have a
True.
camera pointing at your target system, you already have a very high level of information already. So you probably don't even need that malware installed that does the brightness thing. But that's why I was saying it seems like one of the more fun attacks. Like, oh, cool, you can do this, but you're not really gonna do this in a practical context.
Yeah, and I mean it also is one of those things like the title gives it all away.
Yeah, it kind of spoils it. Spoiler alert. But yeah, not too much to talk about there. F-Secure Labs put out a report, though, about forging Swift MT payment messages. So Swift, it's pretty commonly used for international transfers. If you've heard of a Swift code, that's what they're talking about.
Yeah, to relate to that, this brought back lots of bad memories for me dealing with financial institutions and assessments with them. So yeah, I just want to kind of do a quick shout out to this paper or this blog post. It does cover an attack in theory. Like, basically, the attack that it covers is if you have somebody who's already in the privileged position of being able to inject messages into the back office, like payment system message queues, who's able to inject a spoof or like their own Swift message, then they can inject their own Swift message and it'll be trusted by the system. It's one of those things. It's like, of course, but they spend a lot of time talking about architecture, talking about what the messages look like and the different types of queues you might run across and how they're being filled all around. And so while their attack is fine, it's kind of a given, somebody with a high level of access to anything on production can do things that impact production. But it spends so much time on all of these other details. I think it's really worth the read if you're interested in some of that banking technology, or in particular, obviously, in Swift, in some of that architecture. Like, there's a lot of good information here that you're not going to come across really easily, which I think is the real benefit of this blog post, is just all the information that's laid out right here for you. And they admit that, like, the attack itself just relies on, somebody that can inject the message, which is... it's a fair thing. Like, you target this one person, as they mentioned. You get the message queue admin, you target them, compromise them, and now because this is a back office system, you're not dealing with all the front end stuff like multi-factor authentication. You're not worrying about any sort of alert on like a transaction happening. There's nothing really there. It's just the raw message that goes out between the banks, basically.
So it's another good reference point for if you're looking at that area to get some background knowledge on it.
Yeah, like as a really quick get an understanding of it. Because even one of the difficulties, and they mentioned that, kind of quoting the article itself, I've rarely seen or heard of this happening in practice or in the wild, perhaps because it clearly takes a lot of work and there's a huge margin for error. However, if an adversary spent enough time inside your network and has access to the right documentation and resources, this may be a viable attack vector. It definitely is a viable attack vector, but the other thing is it's also a recognized attack vector. That yes, people with a high level of access to production systems are able to potentially compromise that. And they actually talk a little bit about some of the protections you might at a minimum see. Like, they talk about the fact that like whoever this admin is probably going to have to use a jump server. They're probably going to be like, it's going to be a jump server that's whitelisted with just the host that has like only their host is the whitelisted access. And other things that might actually exist in practice. There might be message signing, which then would actually make it difficult for an attacker to compromise because they need to be able to sign the messages also, presumably using a key that they wouldn't have access to or wouldn't have access to without a password. So, I mean, there's a lot to it. Like, this is one of those attack vectors that's recognized already, and it's just because it's recognized, there's a lot of defense kind of in place on protecting that, and a lot of auditing and logging that's also in place. Should that be compromised? Nonetheless, like I said, it's one of those areas that it's sometimes hard to get a lot of good information on it. They say, if the attacker has access to the right documentation and resources. And sometimes that's harder than it might seem. Even just figuring out what message queue to send things to can be quite difficult. Like, a lot of that information is actually kind of locked behind need to know type setup. So, I thought it was a really interesting write-up, though. And it covers, obviously simplified, but it covers it reasonably well. So I want to kind of give it a quick shout out, and I believe you had a blog post that you wanted to shout out.
Yeah, there was a post a couple days ago published by Azeria Labs. They've, she kind of has this 3-part series going on with hitting iOS, which is always a fun target because it's one of those targets where it's really complex to hit with exploits, especially when you're talking about Heap is already kind of complicated to hit. So there were already 2 parts out on it. So part 1, Heap exploit development on iOS, and part 2, Heap overflows and the iOS kernel Heap. And this 3rd part that was just released 2 days ago was about grooming the iOS kernel Heap. So I just wanted to shout it out because it does, these articles are pretty good. If you scroll down the page, you can see they have these neat diagrams and stuff like that, and it's more accessible than a lot of the other stuff you'll see for iOS. So if you're interested in iOS, and maybe you want to start looking into how the Heap works and stuff like that, and potentially get into exploiting it, I think these articles are good. I wanted to give them a bit of a shout out because I just I saw it. I think I saw it yesterday, but it just looks like one of those articles that's good for getting some of that background knowledge on iOS. So yeah, just wanted to shout that out quickly. So that wraps up all of our topics. I did want to circle back to a point with the no V8 exploitation made by some dude earlier. So I was planning on doing a stream for V8 exploitation. V8 is the Chrome JavaScript engine. I wanted to look into that. I did discover that the issue I was going to look into was already written up. So, I was going to do this stream yesterday, but the write-up kind of demotivated me. But after talking with Z a bit, I might actually revisit it this week. So I might be doing some streams this week looking at a V8 issue I found and trying to exploit it. Even referencing the write-up, because I don't know anything about V8. I've done WebKit exploitation. I've never done V8 exploitation, though. And my WebKit exploitation was fairly limited to 1 or 2 bugs. So, I don't have a lot of interest in. I have a lot of interest in that area. I don't have a lot of knowledge in that area. So I think it would be cool to stream that, just because showing how to get some of that knowledge and showing some of the research that goes into it, I think could be valuable. So I might do some of those streams during the week. We'll put it out on the Twitter and in the Day Zero Discord when I'm doing those streams. But yeah, I just wanted to, mention that I could be doing those during the week, but they won't be scheduled on the Fridays, like I was saying at the beginning of the show. We're not going to be doing the scheduled, Friday stuff anymore, just because it's, it's hard to keep it consistent. But yeah, I think that pretty much sums up all of our topics. If you haven't checked out our YouTube, it's in the link down below. You can check out the YouTube there. We also have Spotify. We have our Discord, and Anchor. Anchor's the other thing that we're on as well, that you can check out. So yeah, make sure to check us out on those for all the previous episodes and stuff like that, and for getting VODs for future episodes. We'll be back again next Monday at 3 p.m. Eastern on Monday, and yeah, we will see you guys then.